Hello, this is Michael Robertson, Environmental Health Regional Specialist with the North Carolina Department of Health and Human Services. This presentation covers the rules governing the protection of water supplies. The rules governing the protection of water supplies can be found under 15A, NCAC 18A 1700, and can be downloaded from the North Carolina Division of Environmental Health website. Please make sure to have a copy of these rules to reference during this presentation. So facilities that are regulated under the 1700 rules can include food service establishments such as restaurants and food stands, meat markets, temporary food establishments, and limited food service establishments. We can have adult and child daycare centers, lodging establishments such as hotels, motels, bed and breakfast homes, bed and breakfast inns, institutions such as nursing homes and hospitals, schools, residential care facilities, public swimming pools and spas, tattoo artists, and migrant housing. So essentially anything that's under our inspection is fair game for the 1700 rules. So let's open our rule books and let's look at Rule 1720, which deals with water supplies. What it states is that our source of water is going to be obtained from either a community system or an on-site source that is properly located, constructed, maintained, and operated. So typically when you're out doing inspections, these are the two types of water supplies that you're going to see. You're either going to see a community system reference or you're going to see an on-site supply reference, either one of those. So let's start by talking about what a public water supply system can consist of. There's three different types on your screen that you can see. The first type being a community system. And this is typically what you're going to see out when you're on the field doing inspections. A community system by definition is characterized as 15 connections or 25 or more users for more than 60 days per year. And what this is going to typically serve is going to be municipalities such as cities and towns or large residential communities and neighborhoods. Moving down to non-transient, non-community, this is defined as less than 15 connections and serves at least 25 of the same persons for more than 6 months. So think about that. Non-transient, which what the definition of transient is, non-transient, non-community. So naturally, this is going to be a smaller system. And again, it's going to serve at least 25 of the same persons for more than 6 months. So look at that as a large nursing home or school, because the children are going to be in the school for typically more than 6 months, and your residents in a large nursing home are also going to be residing in that facility and using that water supply for at least 6 months. And then the last type would be transient non-community. So again, think of the word transient, what transient means. It means less than 15 connections, so again, a smaller system, and it does not serve the same 25 persons or more for more than 6 months. So think of that as your restaurants and your lodging facilities, because people are going to come and eat, they're going to come stay in the lodging facility, and then they're going to leave. We're not going to have the same 25 persons there for more than 6 months. So you may see these terms on some of the older inspection forms, on some of the types of facilities that we regulate. So we wanted to just take a quick second and let you know what each one of those means. So the public water supply section in North Carolina has a public water supply search that you can go online and you can look for the different types of systems that they regulate. They have a box there for if you know the ID number, you can put the ID number in. If you're not sure what the ID number is, you can put the water system name, and then you can also put the county, and you can search, and it will give you the information on that water supply. This is very helpful when you're out in the field and you're thinking that I'm not quite sure if this is a community system or a large system that might be under public water supply purview. So it's good to always double check and do a quick search to make sure that you're dealing with either a community system or you're dealing with a private supply. So continuing on with Rule 1720 under water supplies, we want to make sure that our on-site supply is in a good location. It's sited in a good location where it's not going to be prone to areas of flooding. We're not going to have it inundated by flood waters when we have natural events going on out in the field. And we want to make sure that it meets the setbacks that's based on when the well was drilled. And that's very, very important. There are specific cutoff dates that you've got to be aware of when you are out here looking at these wells, when you're in the on-site wastewater program, the water protection program, and you're siting these wells, and also when you're out doing inspections and come across a facility that has an on-site supply. We want to make sure that we're analyzing and regulating those properly. So let's take a look at some of those setbacks here. One of the very, very, very important things to remember when it comes to 1700 rules is July 1st of 1993. That is a pivotal date that you need to remember when you're dealing with the 1700 rules, especially with setbacks, because that is when a lot of your setbacks changed. That's when a lot of the different requirements change. So you want to be very mindful of that date and know when the well was drilled. So the first thing we'll look at is for wells that were constructed on or after July 1st of 1993. So that are wells that were drilled anytime after that date up to the current time or the present time. The setbacks from a septic tank or nitrification field, it's got to be at least 100 feet. So if you're an on-site wastewater person or you dealt with on-site wastewater and water protection, that's something that you hear a lot, or that's a lot that you deal with, even with the residential private supplies and things like that. So that's kind of similar to what you deal with in the other programs. A building foundation, we want to be at least 50 feet from a building foundation. Any types of surface water, we want to make sure that we're at least 50 feet away from surface water. We're at least 100 feet from any chemical storage. And there is quite a few other different setbacks that are listed under 1720C2. So if you look at 1720C2, there's a whole list of different setbacks that we need to be concerned about when we're talking about a water supply that is serving one of our establishments that has been constructed on or after July 1st of 1993. Now, you see a little bit of change here when it comes to the setbacks when we're talking about wells that were constructed before July 1st, 1993. We have some reductions in a couple of setbacks, and I've got two on the screen here that are the most important ones, and that is you see our septic tank and nitrification field setback drop from 100 down to 50. So that's very important when we're talking about facilities that are being served by an older well. That's why it's very, very important to know when the well was drilled and to know what was permitted and what's out there and what's serving those facilities. You can also tell that the building foundation setback has dropped from 50 to 25 feet. So that's also something that's important. So keep that in mind with these older wells. Again, the other setbacks for the construction before July 1st of 1993 is going to be found under 1720C3. The other ones were under C2. This is going to be under C3. There's too many to put on the slide in this presentation. So just make sure you go to that section and read through and make sure you understand what those other setbacks are. So let's take a look at for wells that were constructed and serving a regulated facility before July 1st, 1993. So let's take a moment and think about that, because that's kind of a loaded concept there. So think about a facility that you have had permitted since 1990. So that was prior to July 1st of 1993. The well was drilled back in 1990. The facility was initially permitted in 1990. We're going to be looking at these setbacks right here. The only thing we're going to be looking for is that the septic tank or nitrification field is at least 50 feet away from the well, and that any other subsurface ground absorption waste disposal system is 50 feet. Okay, so keep that in mind. These are the things that we're going to be looking for these facilities only. So again, the facilities that were permitted or regulated prior to July 1st, 1993, and with a well that was constructed prior to July 1st of 1993. These are the two setbacks that we're going to be looking for. So you see there's nothing in there about building foundations. There's nothing in there about any other. These are the two things that we're going to be looking for. So I want to make a little note here too, that if there are different minimum horizontal distances or requirements that are set forth by the Division of Environmental Management. We want to make sure that we understand that those should be used, because if the Division of Environmental Management has a situation out there, whether it be contaminated water supply, contaminated soils, and they have these setbacks set in place for water supplies out there, we want to make sure that we understand that those distance requirements should be used. However, we need to have that in writing from the Division of Environmental Management. So what we need to do is have the owner, licensee, or permittee provide a written copy of those distance requirements from the Division of Environmental Management, so that we can keep those in the file and make sure that everybody's on the same page, and make sure that we know that what those individual setbacks are from DEM. So now let's move on into 1721, and let's specifically talk about the well casing. Now, keep in mind that these are very, very important numbers that you need to be thinking about. We already talked about how July 1st of 1993 is a very, very important concept to remember, as far as a very, very important date, because it has a huge impact on our setbacks and location of our wells. When it comes to casing, these are very, very important numbers as well. So for a well that was constructed after July 1st of 1993, the well casing shall be terminated at least 12 inches above the land surface. Remember that number. So after 7/1 of 93, you're going to be 12 inches above the land surface. All right. Now, how about if we have a well that was constructed prior to July 1st of 93? So that well casing is going to be terminated at least 6 inches above the land surface. So again, that is why it's very, very important to know when the well was drilled, so that you can make a good determination on, how high the well casing is supposed to terminate above the land surface. So again, just a quick review: wells constructed after July 1st of 93, the well casing is going to be terminated at least 12 inches above the land surface. And for a well constructed prior to July 1st of 93, the well casing is going to terminate at least 6 inches above the land surface. Now let's look into our wellhead protection. We're moving into Rule 1722. For wells that are constructed after July 1st of 1993, we're going to require that a hose bib be provided with a backflow prevention device for obtaining water samples. Okay, so that hose bib is going to be provided for those wells. We're going to ask for and require a continuous bond concrete slab or well house with concrete floor provided. So if you see in the picture, we have a picture of a concrete slab under a well house that protects the wellhead. Now keep in mind that there's a little caveat here. For wells that were permitted prior to July 1st of 93, there's that July 1st again, this is not going to be required. So the things on this slide, the hose bib with backflow prevention and the continuous bond concrete slab or well house, this is not going to be required for those wells that were permitted prior to July 1st of 1993. Okay, so keep that in mind. Now, when you're talking about the location of the hose bib, when you have an offset jet pump installation, the hose bib can be installed directly downward on the pressure side of the jet pump piping. So that way it's going to be more effective for use when it's set up in that manner. So again, let me reiterate that. When you have a jet pump installation, an offset jet pump installation, the hose bib shall be installed directed downward on the pressure side of the jet pump piping. So keep that in mind if you're dealing with that type of setup. So let's take a look at this picture of a typical wellhead, well casing that you will see out in the field. And I'm going to highlight some of the important things, important terminology that you need to be aware of. So of course, we just talked about the well casing. And again, depending on when it was drilled and permitted, you're going to be looking at either 6 inches or 12 inches. We have our well seal. So that is the black round seal that goes around the top of the well. And basically that is going to protect the well from, particles and debris and water and things from insects from getting into the top of the well and contaminating the well. Now, if it should have a rubber gasket on it, and if you cannot see the rubber gasket, when it's seated into the inside of the well casing, then that means that it is properly sealed. If you see the rubber gasket all kind of hanging out around it where it's been mashed in, it may not be seated properly. We have our well vent. It could be a piece of PVC with some little slits cut into it. It could be kind of a rounded type elbow with a screen on it. And the main thing about this is this allows the well to breathe. It allows the pressure to regulate inside of the well, and it also prevents the screening and things like that on the vent, prevents your debris and insects from getting down through that opening. So we have our power line entry. So this is our electrical line going down to the pump, feeding the pump. We want to make sure that when that goes down through that opening, that we seal that with some caulking, again, to keep insects and debris and things from getting down into the well and potentially contaminating the water supply. Then we talked about earlier about having a hose bib or a sampling port. You see that there's a faucet that is on the side of the well there. And then here is a picture on the right-hand side of the screen of a typical backflow prevention device. It's not very expensive, that they can screw on to the end of that hose bib or that faucet in order to provide that backflow prevention. So continuing it on with our wellhead protection under 1722, we want to talk about our concrete slab requirements when a concrete slab is required. Again, these are very, very important numbers to remember when you're talking about wellhead protection and the concrete slab. We want to make sure that the slab extends at least 3 feet horizontally around the outside of the well casing. So that's going to be measured. If you measure from the outside of your casing going down in the ground, whether it's a 2-inch casing or a 6-inch casing, whatever diameter it is, you want to measure from the outside of that casing to the edge of the concrete slab, and that's where we're going to require our 3 feet. We want to make sure that it is at least 4 inches thick. So we want to make sure that we've got that minimum 4-inch thickness. And when they are forming that out, if you see in the picture, when we're forming that out, we want to make sure that we get it down in the grade. We want it sitting on top of the ground, because if it's sitting directly on top of the ground and water comes off the hill or water comes down the grade, it could wash up underneath it and undermine the slab and cause it to crack, and also siphon water down to the casing, which is what we're trying to prevent. And we want to make sure, again, along those same lines, that we're sloping it to drain away from the well. So if we have water coming off a hill or coming down the grade, if we've got a little bit of a slope on that concrete pad, that will help shed that water away from the casing. And that is the main thing about the pad, is to try to divert water and keep water away from that well casing and keep things from trying to siphon down into that well. So here's a picture of a typical 1700 well that you may see out in the field. You see that you've got your concrete slab around it. We have the wellhead with our 12-inch casing coming up out of the ground. It does have a pressure tank out there. It's got a hose bib on there. It's kind of hard to see the vent and the wire opening, but kind of wanted to let you see what you kind of show you a picture of what you may see when you're out in the field. Sometimes these may be close to the facility. Sometimes they may be out like here in the woods. You might have to go look for it, but that's when it's good to talk with your supervisor, your water protection folks, or inspectors that have regulated facilities before, so that you understand and know where these water supplies are out in the field. So take just a second and think to yourself, what is wrong here? What are some things that you would have an issue with if you walked up on this well and you were trying to assess it for compliance with the 1700 rules? So think about that, and we'll go forward and talk about the first thing here that we see is kind of the first thing that pops in your head probably is that we need a backflow prevention device here. So one of those little screw-on backflow preventers would be sufficient here. So that would take care of that. We see a picture of our little vent. Our little PVC vent has broken off. So now we have a small hole that's in the top of our well seal that is going to potentially let debris and insects down into our water supply to potentially contaminate our water supply. Our well still looks to be in pretty bad shape. It's very rusted, very corroded. It may not be as sealed as it once was years ago, so it may be time to go ahead and replace that. You might also say that the asphalt around the well casing, you see that we've got some seams here where maybe asphalt was poured up on to the edge of another pouring of asphalt. We may have concrete underneath there. We've got a metal post that's over here. Any one of these things out in the middle of a parking lot like this can divert water down towards our well and cause water to pond up around our well. If you see the asphalt around that well looks quite damp in comparison to the asphalt around it in the general parking lot. So these are all potential areas where water can get trapped out underneath that asphalt and siphon towards that well and contaminate the water supply. And you can also see that the wire opening down probably needs to be recaulked as well. So several things that this wellhead needs in order to be brought back into compliance with the 1700 rule. So let's take a look at this picture. What would you say is wrong here? If you walked up on this well out in the field and you're trying to assess compliance with the 1700 rules, what are some things that you would see wrong here? So let's look at one of the obvious ones here. We've got a missing backflow prevention device. So typically what you're going to find out in the field is they were permitted with one and then somebody hooked a hose to it and or either took it off to get a water sample and never put it back on. So that's typically what you're going to see out in the field, and that's what a lot of them have gone without or have lost those backflow prevention devices. Another obvious thing wrong here is that we don't have our correctly sized pad. We do not have at least 3 feet measured from the outside of that well casing. Not quite sure what the thickness is on that either. We'd have to dig down a little bit further, but we know for a fact that we do not have our 3 feet measured from the outside of the well casing. So now let's talk about 1723, and we're going to talk about springs. Now, you're typically not going to come across a spring. When I worked in the mountains years ago, we had a couple of older facilities that were on springs, and eventually they ended up drilling wells and hooking on to properly located and tested wells. But you may have a spring out there, you know, in the mountains or out in the rural areas. You may still have a facility that is utilizing a spring, and that's okay. But we need to also make sure that they are in compliance with the 1700 rules. So existing springs are approved if they are serving regulated facilities on or before July 1st of 1993. So again, when I worked in the mountains, I did have a couple of places that were operating prior to July 1st of 1993 and had those springs in use before then. So again, if they were in operation and serving a facility, a regulated facility on or before that magical July 1st of 1993, they were approved. Okay. Now, that does not exempt them from having to meet water quality requirements. Okay. So if fecal coliform bacteria is detected in the spring, disinfection of the spring is going to be required. Okay, so we're going to have to follow our disinfection procedures in order to get to take care of the fecal coliform bacteria. Now, if we are finding chemical constituents, then we're going to have to figure out how to get those constituents out of that water supply. We're going to have to figure out how we're going to get those removed. If total coliform bacteria is detected, then disinfection of the spring is required, but they can also use continuous disinfection if needed. So we're going to hear that again in the future when we're talking about a little bit more later on when we're talking about disinfection and continuous chlorination. But same concept. If we've got fecal coliform bacteria, that's a no-go. We're going to have to get disinfection. We're going to have to get that taken care of. Again, if they only have total coliform bacteria, which is a lot less dangerous than fecal coliform bacteria, we're going to make sure that we get disinfection of the spring. And then again, if we continue to have that total coliform bacteria popping up again, then we may look at our continuous disinfection methods. If water quality requirements cannot be corrected, Then we're going to look at Rule 1725, and we're going to follow our requirements for permit action. So unfortunately, we will have to go down the permit action route if we cannot get the water quality requirements taken care of. And a new water source may be necessary. Like I said, in the case that I had up in the mountains, both facilities ended up drilling new wells and getting onto a well instead of their existing springs. So just a little bit more about springs. They should meet 2 NCAC 9C 0703. And that is if it serves a facility permitted or licensed after July 1st of 1993. And this is also required when a new spring is being developed. So anything that's after July 1st of 93 and anything that is brand new that they're trying to develop to bring online for a regulated facility, it will have to meet those regulations. Okay. These rules require a two-step process of evaluating a spring to determine if it's safe for public use. And springs shall not be connected to the establishment until it is deemed compliant with the rules and written certification is received from the owner of the establishment or a registered engineer. Okay. So bundling all this together, what this is trying to say on this slide is that it is a lot. It takes a lot to get a new spring up to standard and to meet the rules, because the very nature of a spring and how things can change with a spring. So it is a very lengthy process to get these permitted and get these licensed, but there is a way to do it. And if they can meet these rules, then it is possible. So we want to make sure that if someone comes to you and approaches you and wants to use a spring, that you're able to give them this information that's listed in 1723. Now, if you're out there in the field and you notice that there is a facility that is being served by a spring, you may see one of these types of setups out in the field. You see that you have a spring box. It's got a very sturdy composure to it. It's got a very sturdy lid. It's locked and secured to prevent any tampering. You may see a small spring house, which is located on the side of a hill on the right-hand side. So you can see these are typically the types of setup that you may see out in the field. So it's something to be aware of if you're out looking at water supplies, or if you're out on a site looking at different things if you have a new facility that's coming online that needs to go through plan review, or someone that's going through a transitional. Just be mindful of these when you're out in the field. So let's take a look at Rule 1724 when it talks about disinfection of water supplies. So water supply serving a regulated establishment is disinfected when we complete construction. So once the well is drilled and construction is complete, and before we can hook it onto our permitted facility, we want to make sure that we are getting it disinfected. We also want to make sure that it is being properly disinfected after maintenance or repairs. And I'll give you a story that happened to me years ago. I had a well pump that was replaced, and the company pulled the well pump out of the well with all the plumbing and the wiring and everything that comes along with it. And the well was located in the middle of a cow pasture. So naturally, it's probably going to pick up certain things out in the cow pasture that's not very appetizing or not very positive. And they replaced the pump, put the pump and all the plumbing and wiring that back down in the well. Whether they disinfected it or disinfected it poorly is I don't know. But all I know is when I went to go do a regular routine inspection and I sampled the water supply, it came back with fecal contamination. So that is why it's very important to make sure that after there's maintenance or repairs done to the well, where the plumbing and the piping and the wiring and everything has been exposed to contamination, we want to make sure that we are getting proper disinfection. Also want to make sure that if we have a report of a positive coliform sample, it's been confirmed, that we're going to go back and make sure that that disinfection is done properly. And we'll talk about that a little bit more here in just a second. Typically, you're going to see our water supply is disinfected using a chlorine solution. So taking a look at 1724, we want to make sure our chlorine solution has a residual of 100 milligrams per liter, and that's going to be placed in the water supply. It's going to be placed in the supply in a manner to contact any water contact parts or materials above the normal water level. So we want to make sure that, again, all of the piping and all the wiring and all the sides on the inside of the well and the casing are going to be make contact with this chlorine solution to take care of any contaminants that may be left behind. We want to make sure that this chlorine solution remains in the water supply for at least 24 hours. We want to give that chlorine a chance to work. We want to make sure that it has ample time to make contact with all of the surfaces inside of that well. We want to make sure that the water supply flows to waste until no chlorine disinfectant can be measured using a test kit. So after that 24 hours is up, we want to make sure we go ahead and pump out that chlorine solution and flush that well out so we can make sure that we get that taken care of. If you're served by a septic system, I would recommend that you just let this run out on the ground outside. I would not run it through my septic system because that might have a negative impact on the good bacteria in your septic tank and your septic system. If you take a look at the right-hand side, you can see that this is kind of a typical setup that someone would use to get a good circulation and good disinfection on a well. You see the wellhead set up. Circulate the chlorine solution within the well. Adequate circulation within the well is needed prior to turning on the faucets in the house. So they've taken a garden hose and connected it to the hose bib. You've got the flow going down through the vent hole or any other hole that you can find on the top, on the inside of the well seal. We're letting that water pump up through the faucet, run down through the hose, down back into the well so that you're getting that good circulation. And then after that, we want to make sure that all of our fixtures in the facility, whether that be sink faucets, toilets, any other water using fixtures in the facility, that we get a good flow of chlorine going through all of those fixtures. We don't want to leave behind any bacteria inside of the plumbing in the structure, because what could happen is any bacteria that's left behind could eventually start to rear its ugly head again and start to multiply and grow, and then we start getting positive samples again. So not only you want to think about flushing out the well itself, you want to make sure we're flushing out all of the fixtures inside of the facility as well. So the NCDENR has a guide here on how to properly disinfect your water well. It is online. You can search NC how to disinfect a well. You can find it online. A lot of counties have that on their website. Other counties or districts may have their own procedures. It just depends. A lot of your well drilling companies may have procedures, but it's good to have something that you can hand to an owner or an operator of a facility to let them know, hey, here's some procedures that you can follow to make sure that we are properly disinfecting the well. However, it is always recommended that you let the owner operator know it's probably good to have a licensed individual, either a licensed well driller or a licensed water operator, to come in and do that for them. Typically, people will pour gallons of bleach down the well, and it may not get the right disinfection. You might have somebody use too little or too much chlorine or calcium hypochlorite. So it's very important to make sure that the operator understands, they have a right to do it their own, but it is good and recommended to have someone who is licensed and experienced to go out and take care of that for them. So talking about disinfection. Again, moving it back into springs for just a second. When we're talking about disinfection of a spring, we want to make sure that the enclosure is disinfected upon completion of construction, maintenance or repairs, pump installation, or if we have found a positive coliform sample. We want to make sure that the interior walls are washed and swabbed with at least 100 microgram milligrams per liter of chlorine solution. We want to make sure that the disinfectant is poured into the spring, the service pipe is plugged, and the water is retained in the spring storage for at least 24 hours, or it is continuously being fed into that spring for at least 24 hours if it cannot be plugged and retained. We want to make sure that this chlorine solution is flowing to waste until no disinfectant can be measured using a test kit. So those are some guidelines on how to disinfect a spring if we need to. So now let's move into water quality, which is found under 1725. Now this is a very important rule when it comes to us as environmental health specialists in the food and lodging program, because it talks about our different types of contamination, what we're looking for, and what the actions are going to be when we find that contamination. So 1725 is going to require that 2 consecutive bacteriological water samples are taken at least 48 hours apart when we have the initial use of a water supply, so that would be prior to permitting or licensing a new facility, after construction, maintenance, or repairs, or pump installation, and after a positive coliform sample. So again, after each one of those 3 items, we're going to make sure that we get 2 consecutive samples checking for bacteria that are collected at least 48 hours apart. Now that's important. That is what is actually in that rule. So prior to sampling, we should be checking our water for chlorine residual. Whether you have the chlorine test kits or tablets or whatever you guys use out in the field, it's important to make sure that we're not getting any chlorine residual, because we don't want there to be a false negative. Because what will happen is eventually when the chlorine residual reduces itself and dilutes itself over time, you may get that bacteria reoccurring in the future. So we want to make sure that we're checking the water supply as it is without any chlorine residual. So keep in mind that a confirmation means that we have 2 consecutive positive samples. So we don't have a confirmation of coliform bacteria until we have 2 consecutive positive samples. That's an important concept for you to remember, okay? So this is typically if you send your water samples off to the North Carolina State Laboratory of Public Health in Raleigh. This is typically the certificate of analysis that you're going to get back from them. Very helpful, is good for record keeping. I know that their records are available online, so you can search them by name or search them by county. So you can see we've got our demographical information up at the top. We've got our data collection information in the middle, and then down at the bottom you see total coliform and E. coli, which would be our fecal coliform, and you see that it's either going to be present or absent. And for this particular sample, we were present for total coliform. So now you would move forward and figure out, okay, now do I need to go get my second sample, or is this my second sample? This is my confirmation sample. What am I going to do next? Okay. So we've got that positive water supply sample. We've got that either total coliform or fecal. We've got our second one. We've got our confirmation. So what are we going to do now? So the first thing we're going to look at is water supply is deemed an imminent health hazard if we have confirmation of the presence of fecal coliform bacteria. And you see fecal is underlined in red, okay? So we have fecal coliform bacteria has been confirmed with our 2 samples in our water supply. We have an imminent health hazard, okay? So we're going to issue an immediate suspension for that to our permitted establishments. And if it is a licensing agency, if it's a facility that is licensed by another agency such as DHSR or Child Development or somewhere like that, then we're going to make sure that we are notifying them to let them know what's going on, okay? There's also a chemical issue here. If you've got chemical constituents present at levels determined by that's hazardous by the environmental epidemiology section, that is also going to constitute an imminent hazard, and we're going to issue that immediate suspension, or we're going to notify the licensing agency for the licensed facility. So either one of those 2 items that you find, we're going to have an imminent health hazard on our hands. Now, a water supply is going to be deemed unsafe for use if we have a confirmation of the presence of total coliform, okay? So you see total coliform is underlined in red, not fecal. So if we have a confirmation of the presence of total coliform, we're going to deem it unsafe for use. Or if we have chemical constituents that are present, but our levels are not at a, we don't have a level that constitutes an imminent health hazard by the environmental epidemiology section. So they're there, but they're not going to cause an imminent health hazard. So we're going to deem that unsafe for use. So either one of those two cases, we're going to issue an intent to suspend. We're going to notify our licensing agency if the facility is licensed. So again, DHSR or Division of Child Development, anything like that, we're going to make sure that we are notifying them if we have an unsafe source. After a water supply has been disinfectant, we're going to make sure that we check the water supply for our chlorine residual using a test kit. We're going to collect our sample using approved sampling techniques, and we're going to make sure that there's no treatment procedures between samples. So that is where we're moving from our immediate suspension. So if we've got our hazardous chemicals or we've got our fecal coliform bacteria, they're going to need to make sure that they get this done prior to us being able to lift the suspension. So they're going to remain closed until we can get this taken care of, okay? If it is a licensing agency issue, we're going to follow the guidance and the requirements of the licensing agency. So I wanted to make sure I put that in there. Again, if it is an unsafe source or if we've got chemicals but they're not an imminent health hazard, then we're going to issue the intent to suspend. They're going to, can remain in operation as long as the licensing agency says that they're okay to remain in operation. If it's a regulated establishment, permitted establishment, we're going to allow them to continue to operate for 30 days, and they'll have that 30 days to take care of this disinfection and get those resampling, get the resampling done. Okay, and again, we're going to checking for that chlorine residual is important because we want to make sure that we're not going to lead up to a false negative later on down the road. We want to make sure sample from that water supply and not a chlorinated sample, and we want to make sure that the operator, if someone's not slipping in some chlorine in between that 48 hours where we're coming back and getting a false sample. So now, if we get our 2 negative samples and they're collected at least 48 hours apart and everything's good, we're going to either lift the suspension, we're going to lift the intent to suspend, we're going to notify the licensing agency for licensed facilities that everything's good to go, and we're going to conduct follow-up samples once a quarter for 1 year. So keep that in mind. Our job's not done yet. If we get it cleaned up and we get the permit action taken care of and lifted, but we still are going to have to follow up on that well once a quarter for an entire year. So make sure you document that in your files. Make sure you put that in your spreadsheets that you're remembering to go back out and get those samples, because we want to make sure that the contamination does not reoccur later on. Okay, I've had situations in the past where I have sampled a well and it was fine. We lifted the permit action. I went back in a quarter or two later and the contamination came back again. So that's the reason to make sure that we are following up once a quarter for 1 year. Again, once the water supply is safe, we're going to lift our permit actions. We're going to contact our licensing agency if it's a licensed facility and let them know that the water supply is safe again. So emergency supply systems, those requirements are found under 1726. What that says, if we have an emergency, we need an emergency supply system in place. Those can be used by regulated facilities for up to 60 days if there is a violation of 1725, okay? So we've got 60 days that a regulated facility can use an emergency water supply system without crossing over into another set of requirements that another agency, the state, like a public water supply, would impose on them, okay? We want to make sure that the source of water is from an approved source. Either that's going to be a community or municipal source, or it's going to be an approved and tested on-site supply. We want to make sure that all the components of the system are disinfected with at least 100 milligrams per liter of chlorine solution prior to use, and after each transfer of water. We want to just make sure that there's no risk of contamination between those times. We want to make sure that we are maintaining a chlorine residual of no less than 0.2 milligrams per liter of chlorine. We want to make sure that that is maintained at all times. And we're going to sample that at least twice daily when in operation, and then the levels are going to be recorded in a log. Okay. Bacteriological samples are collected at least every other week, and reports are submitted to the health department within 3 days of receipt. So this is typically not something you're going to see every day. This is going to be something that may pop up when we have a disaster or an emergency event. And at that point in time, a lot of our emergency management folks are going to be involved. If you get in a situation where a facility needs to have access to emergency water supply, you know, us at the regional level can work with you guys on that and just try to make sure we get that all under control and make sure it's done safely. So let's move into continuous disinfection for Rule 1727, and we talked about this earlier when we talked about with our springs. Continuous disinfection may be used if a water supply has a confirmation of total coliform only. So keep that in mind. This cannot be used when we have fecal coliform bacteria confirmed in the water supply. Okay, only if we have total coliform only. Okay, so chlorine residual must be maintained at least 0.2 milligrams per liter by use of approved equipment. So we have to have approved equipment. We just can't have something that's meant for a swimming pool or something that is homemade be set up to do this. It has to be equipment that is approved to provide continuous disinfection to a water supply. Now, one of the kickers with this is that they must have an operator for this type of system. They can't just, you know, the owner do it or a friend of theirs do it or an employee of the facility do it. It must be an operator who is licensed by the NC Water Treatment Facility Operator Certification Board. So if an owner or an operator wants to go through this training and wants to get certified, then that's fine. But otherwise, they would need to make sure that they locate someone who is licensed as an operator who can come and run this system for them. We also are going to require, when they implement this, a statement from the owner, operator, or permittee that the supply has a minimum chlorine residual of 0.2 milligrams per liter with a contact time of at least 20 minutes. So we need to get that written statement from them. We can't just take it on their word. Typically, the operator is going to provide that information. They're going to keep logs and things like that. So make sure to get that statement from them. When you're out doing inspections, you can ask for the records, ask for the logs. Make sure you get the contact information for the operator so you can stay in touch with them if there's a problem or an issue so that you know who to get in touch with. Now, keep in mind that a UV light cannot be used to meet this requirement. UV light is nowhere in our regulations. It may be in other regulations for other state agencies, but it is not in the 1700 rules. So make sure that if someone wants to use UV light to as a form of continuous disinfection, make sure that you let them know that that is not approved to meet this requirement and that they would need to follow the continuous disinfection requirements listed in 1727. Again, I want to reiterate the fact that this method cannot be used when we have a confirmed presence of fecal coliform bacteria. Keep that in mind. Now, here's a typical setup of a continuous disinfection system. You see we have our well casing coming up out of the ground. We have our nice little vent. We have our hose bib. We have a barrel of liquid chlorine. We have our pumps. We have our pressure tank back there. We have gauges. So this is typically what you would see if you have a facility that is utilizing continuous disinfection. And again, if you have any questions about this, make sure to reach out to your regional specialist and we'll make sure we get you in the right direction. Looking at Rule 1728 at Prohibited Supplies. This is a supply that has a confirmation of fecal coliform bacteria. It is prohibited. Cannot use that if they can get rid of it. Remember, if they can do the disinfection and get that cleaned up, and we get our water samples and everything comes back clean, then we can lift our immediate suspension, or we can use the water supply. However, if we cannot get rid of that fecal coliform bacteria and that water supply is deemed an imminent hazard, then that source or supply is prohibited. So keep that in mind. Cisterns are also prohibited. These are like storage tanks that collect rainwater. Facilities are not allowed to use things like this, such as rainwater or storage tanks like this, to supply their facility with approved drinking water. So want to keep that in mind. Those are listed under 1728. And that is the end of this presentation. If you have any questions about this presentation or any of the information contained in it, please contact your regional specialist. Thank you.